All right, so picture this. You're looking up at the night sky, and you see this huge cluster of stars. Just millions of them all crammed together.
That's Omega Centauri.
Exactly.
Yeah.
It's the biggest star cluster in our whole galaxy. It's pretty amazing to see, but here's the thing. The stars at the center of this cluster are moving way faster than they should be.
Yeah, it's like something is giving them this extra gravitational kick.
So what could that be?
Well, for years, astronomers thought it was a single gigantic black hole hiding in the center.
Oh, wow.
Like we're talking hundreds of thousands of times the mass of our sun.
So a supermassive black hole?
Not quite. They call it an intermediate mass black hole, or IMBH for short.
Okay, an IMBH. Got it.
Yeah.
But wait, wouldn't a bunch of smaller black holes just get flung out of the cluster over time? Survival of the fittest kind of thing?
That's what a lot of scientists thought. It'd be like a cosmic game of gravitational billiards with only the heavyweight champion left standing in the center.
I can see that. And this theory seemed even stronger when they found even faster-moving stars right in the core of Omega Centauri. Like an IMBH could explain that kind of speed.
Exactly. It seemed like a pretty solid explanation.
So case closed. One giant black hole to rule them all.
Not so fast. There's another piece to this puzzle.
Oh, really?
What's that?
Pulsars.
Pulsars. Those are like, what, dead stars gone wild.
Not exactly a disco, but they are the remnants of massive stars that have gone supernova.
Okay.
What's left behind is this incredibly dense spinning core that beams out radio waves.
Like a lighthouse?
Exactly, like a lighthouse beam sweeping past Earth hundreds of times per second.
Wow, that's incredible. Okay, I get the lighthouse analogy, but how do pulsars help us with black holes?
Because those beams are so incredibly regular, it's like the ticking of the most precise clock you can imagine.
Okay.
And by studying tiny changes in those pulses, we can actually measure the pulsar's acceleration.
And that tells us?
That tells us about the gravity it's experiencing. So pulsars are like our tiny spies, reporting back on the gravitational landscape of the cluster.
Precisely.
So what did those spies uncover?
Well, they found something pretty surprising. By combining the pulsar data with those super-fast star speeds, scientists found evidence that points to multiple smaller black holes at Omega Centauri's center. Not a single giant one.
Wow, that's a plot twist I did not see coming.
So does this mean the IMBH theory is totally wrong? Not necessarily. There could still be a smaller IMBH in there somewhere hanging out with its stellar mass buddies.
Okay.
This new research just puts some limits on how big it could be.
So we've gone from one big black hole to a whole party of them. It sounds like Omega Centauri is the place to be. But what does this all mean for us here on Earth?
That's a great question. This discovery actually goes way beyond just one star cluster.
How so?
It makes us rethink how black holes grow and influence the evolution of galaxies.
Wow.
Which ultimately impacts the universe as a whole, including our own little corner of it.
So those little pulsars helped us unravel a mystery that has implications for the entire universe.
Yeah.
My mind is officially blown.
It just goes to show you sometimes the smallest things can reveal the biggest secrets. And this is just the beginning.
Right.
More pulsar data is coming in, which means we can delve even deeper into the heart of Omega Centauri and get a clearer picture of what's really going on there.
Okay, before we get too lost in a black hole of information, maybe we can break this down a bit.
Yeah.
You mentioned intermediate mass, black holes, IMBHs,
Yeah.
and how they're kind of a missing link in black hole evolution.
Right.
Can you explain why those are so important?
Absolutely. We know about stellar mass black holes, which form when massive stars collapse.
Right.
And we have supermassive black holes, the behemoths, at the centers of galaxies. But those IMBHs, the ones in between, well, they're like the missing pieces of the puzzle.
So they're like the teenage years of a black hole. We know where they come from and what they grow up to be, but that in-between phase is a bit of a mystery.
A perfect analogy.
So finding these IMBHs could help us understand how black holes transition from stellar mass to supermassive.
Exactly.
So Omega Centauri could be like a black hole nursery, giving us a glimpse into those crucial early stages. But how do we even go about finding these elusive IMBHs?
Well, there are a few different approaches. One is to look for their gravitational effects on surrounding objects, like the way those stars were zipping around in Omega Centauri.
So even though it might not have one giant IMBH, Omega Centauri is still a prime spot to hunt for them. This is getting really exciting.
It definitely is. Omega Centauri, with all its black holes and pulsars, has become a cosmic laboratory for understanding some of the most fundamental questions about our universe.
And the fact that we can use these tiny dead stars to unravel these massive mysteries, that's just incredible. But I think we need to give our listeners a moment to catch their breath. We'll be back in a flash to explore even more about these mind-blowing black holes. Welcome back, everyone. Are you ready to dive back into Omega Centauri and its black hole bonanza?
I know I am.
We've learned that these tiny pulsars are key to unraveling the mysteries of these cosmic heavyweights. It's like having this network of mini detectives scattered all throughout the cluster, feeding us all this intel on the gravitational forces that are at play.
It's amazing, isn't it?
It really is.
It highlights the power of these seemingly insignificant objects.
Right.
Remember, we're talking about the remnants of dead stars.
Yeah.
Yet they hold the key to understanding some of the most extreme environments in the entire universe.
It makes you wonder what other secrets these pulsars are hiding. If they can tell us about black holes, what else can they reveal about Omega Centauri?
Well, for starters, they can give us a more detailed picture of the cluster's structure and how it has evolved over time. Remember when we talked about those super fast stars near the center?
Yeah.
Well, by combining the pulsar data with observations of those stars, astronomers can actually create a kind of three-dimensional map of Omega Centauri.
A 3D map.
Yeah, showing how all the stars and black holes are distributed and how they interact with each other.
So it's like having a cosmic GPS guiding us through the heart of this star cluster. That's so cool. But let's get back to those IMBHs for a second. You mentioned they're like the missing link in black hole evolution.
Right.
What makes them so elusive? Why haven't we found more of them?
Well, you see, IMBHs don't have the same dramatic flare as their supermassive cousins. They're not surrounded by these swirling disks of hot gas or blasting out these jets of energy that we can easily detect across vast distances.
So they're more like the quiet kids in the back of the class, not causing a ruckus, just quietly minding their own business.
That's a good way to put it. But don't let their quiet nature fool you. These IMBHs are incredibly important.
How so?
Because they could hold the key to understanding how those supermassive black holes form and evolve.
Okay, so how do we go about finding these stealthy cosmic objects? Do we need some kind of superpowered cosmic magnifying glass?
Well, one way is to look for their gravitational influence on nearby stars and gas. If an IMBH is hiding out in a star cluster or a small galaxy, it will cause those objects to move in unusual ways. It's like watching a puppet show. You can't see the puppeteer, but you can see the strings moving the puppets.
So the IMBH is pulling the strings, so to speak, even if we can't see it directly. But isn't that what initially led scientists to think there was an IMBH in Omega Centauri? And then the pulsars came along and changed the game.
Exactly. You're right. The unusual star motions in Omega Centauri did initially point to a single massive black hole. But as we gathered more data, especially from those pulsars, the picture became a lot more complex.
This feels like a cosmic detective story, with each new clue leading us down a different path. So what other methods do astronomers use to hunt for IMBHs? Is it all about watching stars do a cosmic dance?
While stellar motions are a good indicator, astronomers also have other tools in their arsenal.
Like what?
One promising avenue is to look for bursts of X-rays.
X-rays, like the ones they use at the doctor's office. But how do those relate to black holes?
Well, it turns out that when gas falls into a black hole, it gets superheated to millions of degrees and emits X-rays.
Wow.
Now, IMBHs don't gobble up gas as dramatically as supermassive black holes do, but they can still produce these detectable X-ray flares.
So it's like catching them red-handed, or should I say X-ray-handed, as they're enjoying a little cosmic meal.
Precisely. These X-ray bursts can act like beacons signaling the presence of an IMBH hiding in the darkness.
This is getting more and more exciting. It feels like we're on the verge of a major breakthrough in our understanding of black holes. But before we get too ahead of ourselves, let's bring it back to our star cluster of the day, Omega Centauri. What does the future hold for this black hole haven? Will it continue to be a cosmic laboratory for astronomers?
Oh, absolutely. Omega Centauri is like a treasure chest that just keeps on giving.
I like that.
With new telescopes and observational techniques coming online all the time, we're only going to learn even more about this cluster and the black holes within it.
So what specific questions are astronomers hoping to answer in the coming years? What mysteries are still out there waiting to be solved?
Well, one of the big questions is how exactly did this cluster of black holes form in the first place? Did they all start out as smaller black holes that gradually merged together? Or did they form from the collapse of a single supermassive star?
That's a good question.
And what about the future of these black holes? Will they just continue to hang out together in Omega Centauri? Or will some of them eventually get flung out into the vastness of space?
Those are some great questions, and to be honest, I don't have the answers. But that's what makes this field so exciting.
It really is.
With every new observation, every new piece of data, we get closer and closer to understanding these cosmic enigmas. It sounds like Omega Centauri will keep astronomers busy for a very long time to come. But before we get lost in a black hole of speculation, let's give our listeners a moment to process all this amazing information. We'll be back in a flash to wrap things up and leave you with some final thoughts to ponder. Welcome back, everyone. It feels like we've taken this incredible journey to the heart of a cosmic mystery, exploring this bustling star cluster, Omega Centauri, and its hidden population of black holes.
We really have, and we've uncovered so much, from super-fast stars to those amazing pulsar detectives that have completely changed our understanding of what's happening at the cluster's core.
It's really amazing. It makes you appreciate the vastness and complexity of the universe. I mean, who would have thought that tiny dead stars could unlock the secrets of black holes? But speaking of those black holes, we've talked a lot about their scientific significance. But I'm wondering, what does this mean for us here on Earth? Why should we care about what's happening in this star cluster thousands of light years away?
That's a great question, and it's one that astronomers grapple with all the time. On one hand, you're right, Omega Centauri is so far away, it's not like one of those black holes is going to suddenly show up and swallow our planet. But on the other hand, studying these really extreme environments, these cosmic laboratories, it gives us this incredible window into the fundamental laws of physics that govern our whole universe.
So it's not just about black holes, it's about understanding the very fabric of reality.
Exactly. By studying how matter behaves under these intense gravitational forces, we can test our theories of gravity, of space and time, of the very nature of the universe itself.
So in a way, we're not just looking at Omega Centauri, we're looking at a reflection of ourselves and our place in this grand scheme of things.
That's a beautiful way to put it. And with each new discovery and each new piece of data, that reflection becomes clearer, more detailed, and more awe-inspiring.
It seems like Omega Centauri is a gift that keeps on giving. We talked about those IMBHs, the missing link black holes, and how this cluster could be the perfect place to find them. What's next in the search for these elusive objects?
Well, with new telescopes like the James Webb Space Telescope coming online, we now have the power to look even deeper into the universe than ever before. And this means we can look for the telltale signs of IMBHs, like those bursts of X-rays or the tiny wobbles of nearby stars caused by their gravity.
So it's like having a new set of eyes, a more powerful lens to view the cosmos. What are astronomers most excited to see with these new capabilities?
One of the things I'm really excited about is the possibility of finding more black hole binaries.
Black hole binaries? That sounds pretty intense. What are those?
Imagine two black holes locked in a gravitational dance, orbiting each other closer and closer until they finally merge in this massive collision.
Wow.
And these mergers release huge amounts of energy, sending out ripples through space-time known as gravitational waves.
Wait, gravitational waves. Those are the things scientists have actually detected here on Earth.
Right.
Like actual ripples in the fabric of space.
That's right. And by studying these gravitational waves, we can learn so much about the black holes that created them, their masses, their spins, even the distance to their merger.
It's like listening to the echoes of these cosmic collisions billions of years after they happened. That's incredible.
It really is. And with even more sensitive detectors coming online in the future, we expect to detect even more of these gravitational wave events, which gives us a whole new way to explore the universe and all the black holes out there.
It's amazing to think about all the discoveries that are waiting to be made. It feels like we've only just begun to explore the mysteries of the universe. But for now, I think we have to wrap up our deep dive into Omega Centauri. Any final thoughts for our listeners?
I think the biggest takeaway from all of this is that the universe is just full of surprises. We're constantly learning new things, challenging our assumptions, and pushing the boundaries of what we know. And who knows what amazing discoveries are waiting for us just around the corner.
Well said. Omega Centauri might be just one small piece of the cosmic puzzle. But it's a great reminder that even the tiniest objects can hold the key to unlocking some of the biggest mysteries. So keep looking up at those stars, keep asking questions, and never stop exploring the wonders of the universe. Until next time, happy stargazing, everyone.